Hi, I'm James McGuire, and today we're talking about managing data in a multi-cloud world. Certainly a subject that creates a lot of headaches and is full of challenges. To discuss that, I'm joined by someone who knows a lot about the topic. With me is Krishna Subramanian, co-founder and president of Komprise. Krishna, happy Friday to you, and thank you for joining us today.
Yeah, thank you for having me on your show.
And I want to make note, too, of the fact that the Silicon Valley Business Journal has put you on their list of the 2021 top 100 women of influence. So congratulations on that.
Thank you.
Yeah, and
Yeah.
I'm gonna guess, Krishna, like you co-founded the company, you got on the top 100 list. It sounds like you don't goof off too much.
Well, work is fun, right? We're having fun here every single day.
Good, good. I'm glad you feel that way. All right, so let's talk about the challenges of handling data in a multi-cloud world. I mean, a company will have an application on Azure. They'll be storing data in AWS. They might use the AI feed from Google Cloud. They might have a database application on Oracle. They're working with OpenShift on IBM. Certainly, so data is everywhere. So managing data with all these different platforms sounds almost impossible. If you would sort of, how do you draw a portrait of what's going on? Some of the challenges with handling data in a multi-cloud world.
Yeah, it's very interesting because there's been a tremendous explosion of data, and I think we all can see this in our own lives. I mean, just think about the phone you have today and the phone you had 10 years ago, and the quality of the pictures you can take today, and how many more pictures you can take on your phone, how many you can
Right,
store.
right,
You can see that even in our personal lives, data is exploding.
right.
Then if you extrapolate that and say every time you go to the doctor and you take an MRI, or they sequence your genome in the future, or every time you get into a self-driving car and it's gathering statistics as you move around, or every
Hmm.
movie that you watch is 4K or 8K or 10K, all of that is data behind it, right?
Right.
But the big change that has happened in the market over the last 2 decades is that most of this data today is what we would call unstructured data.
Right.
So 80-90% of the data in the world today is unstructured, meaning that it doesn't sit in a database. It's not in a spreadsheet. It's actually file data of different kinds, like genomics data or seismic data or media and entertainment data or oil and gas data, etc. So
Or
most
to
of
give an example, correct me if I'm wrong here. For example, like social media sentiment, someone might be like combing social media platforms to see how users feel about a certain vendor, and they might be expressing emotions, and that becomes unstructured data because it's hard to really put that data to use metrics to describe that in columns and rows. Am I correct in that?
Exactly. That's exactly right. Every tweet you generate, this video that you're recording is
Right.
unstructured data, right?
Right.
So unstructured data is growing explosively, and it's a really big problem for businesses because unstructured data is valuable to a business. It's the lifeblood of the business. So they
Hmm.
have to keep that data around for a long time. And because data is valuable, they never just keep one copy of that data. I mean, right
Hmm.
now you're seeing in the news all this ransomware attacks
Right.
happening with companies. So to protect that data, they usually keep another copy in a disaster recovery site, and then they
Hmm.
keep a few backup copies. So there's 4, 5, 6 copies of every piece of data. And now,
Hmm.
if your data is growing at 20%, 30%, if
Right.
you multiply that by 6 copies, it's really growing by 120%.
Right.
That's the problem enterprises are having. They're running out of data center space. They're running out of budgets. 30 to
Hmm.
40% of their budgets are already being spent on data management, and they
Hmm.
don't have any more room. And then their CIO comes and says, hey, the cloud is cheap, and the cloud can do it all for you. Just move it all to the cloud, right?
Hmm. Hmm.
But it isn't that simple because the cloud is great, but it's not just a cheap storage solution. It also has compute in it, and
Hmm.
you're paying by the hour. So you want to use it wisely for the right things. So there's this notion of right placing of data. So, how do you understand what data you have? How do you move the right data to the right place at the right time and use the right services on it and extract value from that data? Because if all you're doing is storing data in different places, that's not really helping your business. It might help your bottom line, but it doesn't help the top line, right?
Right.
So data
Yeah.
management is
Go ahead,
both of,
please.
yeah, yeah. But that's what's happening. That's what's happening with the cloud. This idea of how do we get the right data to the right part of the cloud at the right time, and how do you use the right services on it? That's spawning a whole market called data management. And this data management problem for unstructured data is relatively new. 20 years ago, we didn't have this problem because we didn't have data at this scale, and we didn't have things like the cloud, right? 20 years ago, the data management problem was take it from disk and move it to tape archives,
Right,
right?
right.
So
Well, you talk about the cloud, and one of the problems with cloud is storage is there's compute there. Of course, as you know, I mean, there is cold storage in the cloud, but then it can be relatively inexpensive because it's archival, cold storage. But of course, then it takes a long time to get that data. It's not the data you're going to be using hour by hour, minute by minute. So it's a question of balancing the different tiers of data, which could be different levels of expense. How quickly do you need that data, and how cheaply can you store it?
that's
Agreed.
exactly
Yeah.
right.
Yeah.
Yeah, if you look at Amazon, when they first started, they had one class of storage called S3, simple storage
Hmm.
service, right?
Hmm.
Today, they have 16 classes and 16 classes and tiers of storage. They have file storage for Windows, file storage for Unix. Then they have different levels of S3, different levels of Glacier. So now putting data in the cloud means which of those 16 tiers do you want to put your data on, right?
Right.
And then to your point, if you want to use it, let's say you want to do a big data analytics project on it, then at that time, maybe you want to move the data to an expensive tier so that you can compute fast on it. And when
Hmm.
you're done with it, move it back to something like Glacier. So
Hmm.
data management is about managing that life cycle of that data and making the right services available to that data at the right time.
So here are these poor companies. They have 6 copies of every piece of data, and the data is growing. 20%. The core data is growing 20% a year, if not more.
Yeah.
How do you see companies? What are some of the the ways they're trying to handle this? They're using tape and rubber bands to hold all together. What are some typical fixes, even if they're not successful? What are companies doing to handle all this now?
Yeah, and I'll give you a great example of a customer that actually just did a webinar with us on AWS yesterday because it's a very relevant customer, I think.
Hmm.
The company is Pfizer, and we all
Oh,
know Pfizer in the
sure.
last year, right? They're the
I've
fourth.
had a couple shots from Pfizer, as a matter, fortunately.
Exactly.
Yeah, yeah.
Right. And so clearly, provided a life-saving vaccine in record time at record scale. And that's what we saw on the front lines. But behind the scenes, that meant a lot of researchers at Pfizer were generating volumes of data, trying to, create this research.
Right.
And they needed quick access to historical data to make that research happen. So what the Pfizer IT team realized is they were not going to be able to build data centers fast enough to address
Hmm.
this need. And so they
Hmm.
wanted to use the cloud in some way. And so what we did is they have petabytes of data. They used our data management software to look across all their data centers to understand what data was actually being used by researchers, what data was cold and not being used
Hmm.
actively. And
Hmm.
then they actually first had us move the cold data to the cloud in a way where we left what's called links or thumbnails on their site, so the research,
Uh-huh.
it looked like it was still there even though the
Hmm.
data was in the cloud, so it didn't require a process change for them. And then we created a data lake of all that data so that researchers can now use the data in the cloud. The next time they have to develop another vaccine, they don't have to bring that data back because cloud is cheap to get in, but it can be very expensive to get out, right? And you don't need
Yeah.
to get out of it if you can use the compute in the cloud properly.
You talked about forming a data lake for all that data, which makes perfect sense. For my own education, why would it use a data lake as opposed to a data warehouse? Why would it all be stored in a data warehouse? What's the difference there?
Yeah, it's a good question. So, a data warehouse is a single place, kind of like when you go to a Costco warehouse and there's stuff
Mhm.
stacked in there, right?
Right.
But all the stuff has to be put in there. Um, and when you have unstructured data, 1 petabyte of unstructured data, it could be, 3-4 billion files.
Yeah.
And
Mhm.
so if you have petabytes of unstructured data and you have to copy it all into a data warehouse, and then if you don't really need it for too long, you just wasted all that time moving all that data to the warehouse.
Right.
The notion of a data lake, it's virtual. The way we do it, wherever your data sits, whether your data is in a data center or in the cloud, we give you a virtual index of all that data and give
Hmm.
you a searchable space so you can find the data you need for a particular analysis and then
Hmm.
copy it into a warehouse for fast processing. So the warehouse is kind of the place from which you can do the analytics, but somebody has to decide what data should go to the warehouse and how to
Hmm.
take it there.
So you're talking about using data virtualization. Am I correct on that?
It is like data virtualization. The only difference is that, the notion of virtualization is, hey, I will take care of everything underneath, and you come to me and I will give you the answers, right? that's
Hmm.
how that's how compute virtualization works. You go to the virtual machine and it abstracts the physical machine, and
Hmm.
it works for compute, but it doesn't work for data
Hmm.
because data is so big. You don't want a middleman in the middle of all your access. It could slow things down.
Hmm.
So we virtualize the data access behind the scenes. So,
Hmm.
you can still go to the cloud to get your data. You can go to your on-premise data center to get your data. But behind the scenes, we give you an index of everything. We move everything. So we don't get in the path of the data. So this is out of the data path.
Interesting.
Yeah.
So let's talk about your products. I mean, I was reading the Komprise website, and it says Komprise puts you in control of your unstructured data. It's not in your vendor's control, so you can know, move, manage, and harness data anywhere. But of course, my question is, unstructured data by its nature is hard to define. So
Yeah.
how does Komprise do this with unstructured data?
Yeah, so as you said, James, unstructured data doesn't have a specific pattern to it, right? That's what
Hmm.
makes it hard.
Right.
But there are things that describe the unstructured data. It's called metadata. So
Right.
like when you like your phone is able to tell you took this picture in at Yosemite 2 weeks ago and
Right.
things like that, right? Because that's metadata it's keeping. So like that, different systems have metadata, and what we do is we look across all that metadata and we analyze it and we put it into an index, a global index, so you can search and find the data you want, and
Hmm.
then we move the data. So we help you get a view of all your data, because today the biggest problem for IT is IT doesn't create the data. Some scientists might have created data and IT doesn't know what's in it, but IT is supposed to manage that data, right?
Hmm.
So
Hmm.
we analyze all this metadata and we tell them, hey, 20% of your data is ex-employee data. They're not even in the company anymore, and you're
Hmm.
wasting millions of dollars, storing it and backing it up, and you could
Hmm.
probably save money on that. Or 80% of your data hasn't been touched in a year or more. You could put that in Glacier in the cloud, and you could save
Hmm.
so much. Or
Right.
10% of your data is really hot. You want to put this on your highest performance storage. That's the
Right.
data you want to put in a data warehouse because your users really want to use it. So
Hmm.
we give that kind of analytics to them. And then our product actually moves the data based on policies. So it either tiers data to the cloud or migrates data or replicates data, depending
Hmm.
on what the customer wants to do. And we do all of this through open standards. So it's not
Hmm.
that there aren't products to move data today. Even storage vendors can move some of their own data, but they
Hmm.
do it in a proprietary way. They do it
Hmm.
inside their file system. And the
Hmm.
problem with a proprietary solution is then you're locked in. So if you move data to the cloud through a file storage system, and then forever you have to run that file storage in the cloud, then you really didn't get the benefit of the cloud, because you have somebody acting as a gateway to your data, and you don't
It,
want that.
it's really a question of vendor lock-in at that point.
Question of vendor lock-in and cost, because if you have to rehydrate everything to that storage solution, that's expensive.
Hmm.
So mobility, cost, agility, lock-in, future proofing, all
Hmm.
these things are affected when you use a proprietary solution. And that's what led us to create the company. Honestly, this is our third company. for myself and my two co-founders, and we created Komprise because customers from our last two companies, our last two businesses got acquired, but many of our customers came and said they're drowning in data and they have this problem, and they needed a storage independent solution that didn't lock them in. And that's what led us to create Komprise.
Interesting. So, I recently talked with an executive from Snowflake, and he was talking about some similar ideas. Just from my understanding, how would you compare with what you're doing with data management and data management as a service with, say, what Snowflake is doing as essentially sort of a data warehouse platform?
Yeah, so data warehouse is basically providing a place that you can run data analytics on, and it is used more for structured data and semi-structured data. And what you could think of us as a virtual data lake for unstructured data, and somebody like Snowflake is complementary to us because we would find the right data and move it into Snowflake. So the unstructured data that you could put in a data warehouse. So basically, if your data warehouse is like a big database, right? A data warehouse, a lot of historical data that you want to analyze often. So, but not all unstructured data fits that profile, because some unstructured data you may not want to analyze right now. You may only want to analyze 20 years from now. So you don't want to be putting it all into a warehouse. So we kind of ingest data into Snowflake. We find the right data to put into Snowflake from places like S3 and Glacier and NetApp and EMC and other file storage.
Yep. Interesting. Okay. And that's another, you've sort of talked about this, but I think it's interesting from your website. You're talking about your product, and you refer to it as multi-cloud data management as a service that frees you to easily analyze, mobilize, and access the right file and object data across clouds without shackling your data to any vendor. So really it's about, in a sense, freeing the customer. They can live in this multi-cloud world, but they can move this unstructured data as they see fit, here and there.
Yes, that's correct.
That's really it.
Mobility. See, people don't understand, but moving data is not easy because data is very heavy. So it's not just like, oh, I know I've got to get these 8 petabytes over there, and it'll just happen, because 8 petabytes could be 30, 40 billion files. Some files could be really tiny. Some files could be massive. Your network may not be able to handle that. You may have it in many data centers. So mobilizing data the right way is not a trivial problem. It's difficult to solve. And we have a background in that. Our background is distributed lightweight computing, distributed scale-out computing. So we basically built software that's really lightweight and is distributed and efficient and can do this, kind of in parallel. So you can get high efficiency, high speed for the right data.
Well, let's look to the future of data management. I mean, certainly, the idea of data management is not going to get any easier as the years go ahead. And I think it's not going to get any less important, because we're going to be drowning in data as the years go, as you mentioned with your example of the 20% of data with the 6 copies. So if you look, say, to the year 2025 or so, a few years in the future, I mean, what we do expect data management to look like then, or what might be a milestone or so, and how might companies get ready for that?
Yeah, definitely. I think data growth, as you said, is continuing to explode. And I think sustainability is going to become a bigger and bigger issue, because even the cloud isn't infinite. Everything is at some point resource bound.
Do you mean environmental sustainability? Just sorry to interrupt, but
environmental sustainability, right? You have all this data. Do you really need to keep all this data around?
Right.
Enough meaningful value out of it so you can condense what you're actually keeping. How do you extract value? How do you run things like AI on your data? Because at the end of the day, how do you train? Today, a lot of the data analytics that's happening is extracting data for humans to analyze. And that's good, but there's so many patterns in this data that could be better analyzed by machines if you could give them the right data to analyze. Right. So I think extract extracting more value from data and condensing data in a sustainable way are two big problems that the industry overall is looking at, because we're running out of room. We are not going to have any more room. Uh,
It's interesting you talk about the idea of artificial intelligence and algorithms, doing the data analytics. And I think I would imagine we might look back at this period and go, oh goodness, the humans were having to look at the data too much. We weren't feeding it enough to the machines. And it seems like we definitely need the help of AI and algorithms to help us, get value from the data.
Yes, definitely.
Yes.
I think there's two elements of AI, and words like AI, I feel they're very broad,
Right.
and so I like to break it down into components. One part of it is machine learning. How do you use prior patterns to learn things? And
Hmm.
that machine learning we're actually applying to data management today. How do
Hmm.
we use, for example, if a pharmaceutical customer's data is very different from a media and entertainment customer's data and the way they use it.
Hmm.
Because we are analytics driven, we actually use patterns from their own data to manage their data better.
Hmm.
That's the kind of machine learning that data management itself can leverage. But
Hmm.
the bigger thing is AI and machine learning on the data itself for the customer. So how
Hmm.
can we make the next drug research that much easier by getting the right data into a Snowflake and making that and AI engine run faster on that data. That's
Hmm.
the next frontier that we're working. We have something called deep analytics in our
Hmm.
product that is geared towards extracting value more efficiently from data for exactly that purpose.
Hmm. Well, it's going to be interesting to track it, to be sure. I mean, it's going to be an interesting portrait as the years roll on. Krishna, I really appreciate you talking with us today. Thank you very much.
Thank you very much. Thanks for having me on the show.